Okay, so my name is Jacek. I work at SoftwareMill, which is a software consultancy from Poland. And I'm mainly a Scala engineer, but also do some other languages around JVM, so Java, Groovy, but mainly Scala these days. Well, recently we've run into some issues around concurrent execution and around asynchronous programming. This was connected with choosing the right, basically choosing the right thread pool for your operations. I mean, when you do Scala, you have you have those execution contexts and those thread pools, and you need to usually really think about it, which thread pool you are using for which kind of operations. So to separate the long-running I/O operations from the other stuff, in order not to block yourself and your application. Actually, we've run into issues when it turned out that we were blocking ourselves, and we needed to really think about it, what we are doing, and then we managed to fix it. Okay, so actually in one of our projects we had a lot of data to process, so that wouldn't fit on a single machine. We were actually using Cassandra for storing that data, and Cassandra has its own recommendations for how big the database should be, how big the drives should be. So we really needed to think about how to design our Cassandra cluster and how to distribute the data among the clusters. So this was I really enjoyed that project because it really made you think about how you're using Cassandra, what are the limitations, and there are always limitations, so you just need to think about them. So I really learned a lot during this project with actually designing the architecture of the distributed data and of the Cassandra cluster. Well, I think there's one general issue with scaling. I mean, when you're sharing data between the multiple instances or between multiple nodes that you have, because this is always going to be an issue, and we will need to be thinking about how to synchronize the data, how not to lose data. Of course, it's always about eventual consistency. So how consistent we want the data to be, and when should it be consistent. But this is always an issue. So when you have multiple nodes, we need to synchronize between them, and this is the core thing that we will need to take care about. Well, I think for me, the biggest change when I started to learn and when I got convinced by some concepts or functional programming was like a complete change of the mindset. So changing the way you think about problems. And it was really refreshing, because when you are used to object-oriented programming, and then at first I did my first Scala course at Coursera, I think, and it was by Martin Oderski, who was talking about this functional programming core concept, and I was like, why should I do that? Well, object-oriented programming works for me. But then after using it for some time, it really convinced me, and it helps you better formulate some of the problems you are trying to solve. And basically, it's always refreshing to have to approach a problem from a different perspective. So this was the main benefit, I think. Well, actually, when I was looking at the agenda before I came here, I was really impressed by the detail of technical detail of talks, because sometimes when you go to a conference, the talks are they just touch the surface and they don't really dig into details. And from this year's agenda, I'm expecting a lot of really technical content, so that you can almost get your hands dirty with all the stuff. So this is really promising for me.